My name is Thirupathi. I am working assistant professor in Marri Laxman Reddy Institute of Technology and Management. Today I am going to discuss the DC machines topic, and this topic is there in the syllabus of BEE in the first year of all streams, and it is come under into the electrical machines. One, these DC machines are very important. Okay, so today we discuss some contents that first the working principle. So first we know that what is the machine. A machine is a device which will reduce the human efforts, that is nothing but a luxurious. For example, if we want to draw a water from a well, we will use buckets, but if we have a motor, by switching on it we can draw water very easily. So by that the human effort will be reduces. Okay, so now what is a generator and what is a motor? Generator is a device which will converts mechanical energy into the electrical energy, and in the same way the motor is also a device which will convert electrical energy into mechanical energy. So here we see the generator which converts mechanical energy into electrical energy, and the motor which converts mechanical energy into electrical energy. Okay, so DC generator, the DC generator's working principle. A conductor when placed in a magnetic field, it cuts the, when it is rotated and it cuts the magnetic flux, and EMF will be induced in the generator according to Faraday's law of electromagnetic induction. So here the important three terms are conductor, magnetic field and the rotation. So when a conductor is placed in a magnetic field, that magnetic lines will be linked with the conductor. So when it is rotated, then that flux lines will be cut by the conductor. So whatever the electrons present in the conducting material, that electrons will gain the charge and they will try to move from one point to the another point. That is nothing but EMF, electromotive force. So whatever the EMF is generated in the conductor, we should know the direction of the EMF of that generator. So by using of Fleming's right hand rule, we can know the direction of the EMF in the conductor. So stretch the three fingers. The three fingers should be mutually perpendicular to each other. So here the thumb indicates the motion of the conductor, and the forefinger indicates the flux direction, and the middle finger indicates the direction of the EMF. So here the easy way to remember is the forefinger in the sense F. The forefinger letter will be start from F. That flux also start from the F letter. So that is that easy to indicate that F, that is nothing but flux. And the middle finger, it is also, we can say it as center finger. Center finger C is nothing but current, and that current is nothing but we can denote it as EMF. So thumb indicate the motion of the conductor, and forefinger indicate the flux direction, and middle finger indicate the EMF direction. Okay, so when the EMF is generated, that EMF equation is BLV sin theta. So here E is equal to EMF, it is in volts, and B is equal to flux density, it is in Webers per meter square, and L is equal to active length of the conductor, it is measured in meters, and V is the velocity of the conductor, and it is meters per second, and the theta is the angle. And these when the theta angle is 90 degrees, the sin theta will become 1. That indicates that it will produce the maximum amount of EMF. Okay, so this is the concept of about generator. So here the generator is a device which will convert mechanical energy into electrical energy, and generator, whenever a conductor placed in a magnetic field, the conductor will be rotated in the magnetic field and it cut the flux, and EMF will be induced according to Faraday's law of electromagnetic induction. So to know the direction of the EMF, we are using Fleming's right hand rule. Here we are stretching the three fingers mutually perpendicular to each other. The forefinger indicates the flux direction, the thumb indicates the motion of the conductor, the middle finger indicates the EMF direction. The next one is the construction. The construction details is same for motor and the generator. Okay, here no difference between the motor construction and the DC generator construction. So in this construction we have two parts. One is stator part which will not rotate, and another one is the rotor part which will be rotates. Okay, so here this is the diagram which contains a single line diagram which contains the parts, and this is the real diagram, the practical diagram. And here the first one is the yoke. The yoke is nothing but outer periphery of the device, and this yoke is made up of cast iron and the cast steel. Cast iron for the small and the medium machines, cast steel for the large machines. And the function of the yoke is it protect the inner devices and it provide the return path for the flux. So when the flux is travel from north to south, then again that flux line should require a closed path. That closed path will be provided by the yoke. Okay, and this yoke is also avoid the shock for human or living organisms. And the next one is pole core and the pole shoe. Here the pole core and the pole shoe are made up of steel, and here if it is a large machine, the pole core and the pole shoe both will be laminated. Here why we are using steel means the steel is have a less reluctance, that is nothing but it have a more permeability, and it is laminated to reduce the eddy current losses. So the laminating is nothing but we have a steel material like a bar and we are making into a pieces, the sheets, the making of sheets, and we are making some insulation between the sheets and make together with a staggered with a tighten, and that will be used for the poles and the pole shoes. Okay, here the pole core and the pole shoes give the mechanical strength for the winding, and here the pole core is used as a magnet. So when the coil is carrying the current, the pole core will be act as a magnet, and the pole shoe it will distribute the flux uniformly, and this pole shoe is in the shape of arc, and it will cover the 3/4 area of the armature core. And the next part is field winding. So in all the machines, whatever the electrical machines we have, we will use the winding as a copper material. Here also we are using the copper material, and here the winding have a classification of two types. One is the concentrated, another one is the distributed. The concentrated, here we are using the concentrated, that is nothing but the winding is wounded at a one part without any distance. Distribution means we will distribute the winding with some distance, so due to that it is called as a distribution. So in the field coils we are using the concentrated type winding, and it is made up of copper, and it is used to produce the magnetic field, and it acts as north pole and the south pole. So when we have a two consecutive conductors, if they have carry the same direction of the current, then there is no production of pole. If that consecutive windings carries the different direction, then there is a formation of a pole. So to identify the pole, we should use the thumb rule. So by using of thumb rule, these wrapped fingers can be considered as magnetic field, and this thumb indicates the direction of the current, or vice versa. Okay, so if the flux lines will be living from north to south, then we can easily conclude that the leaving point is north and the entering point is the south. So by using of thumb rule, we can conclude which pole is north and which pole is the south. So here, if the two consecutive windings carries the same direction of the current, then there is no formation of a pole. If the current directions are different, then there is a formation of pole. If we want to know the pole, which pole it is, north pole or south pole, by using of thumb rule, we can find out the pole. And the next one is armature core and the winding. Here this armature core is made up of silicon steel, and it is also laminated to reduce the eddy current losses. And here also we are using the steel to increase the permeability. Okay, and here it is produces the, so it provides the slots to keep the winding, armature winding, and it is also called as the power circuit, and it is placed on the shaft, and it is a rotating part. And the next one is the commutator, very important one. So commutator is a device which is made up of hard drawn copper, and it have a segments. In between the segments we will keep the mica insulation. So by keeping of mica insulation, the short circuit of two segment will be avoided. So if we are not place any mica insulation, then the two segments will be short circuited. So see here, so here I am drawing a two segment line. So in this two segment line, these will be considered as one end and this will be considered as another end. So this is one coil. If here we are not installed any mica insulations, then these two conductors will be short circuited. So to avoid that, we are using the mica insulation between the two segments. And and the function of the commutator. The function of the commutator is nothing but it will convert DC to AC and AC to DC. So this is the function of the commutator, and it is also called as mechanically uncontrolled converter. So here we didn't have any control system, okay, and it will convert only AC to DC and DC to AC, vice versa, okay. And the next device is braces, the very important one. Here the braces are made up of carbon or graphite, and these braces have a advantage of good conductive nature, and it have a self lubricant. It will not damage the other devices, but it will have a own self lubricant property. So that is the big advantage of the carbon why we are using here. And here another disadvantage is that it have a drop of 2 volts. So the 2 volts voltage will be drops in the braces. So that is the disadvantage we have. And this function of the braces is it will collect the current from the commutator, and the braces can be changed according to the rating of the devices. Here we have a bracing holders. So according to the increasing of the machine, the braces will be also increases. And here we have a brace holder springs. So that will be keep contact with the commutator. So see, if it is a commutator, my left hand is a commutator and my right hand is a brace, okay. So when it is placed or contact with the commutator is a rotating part, so it will be rotates, okay. So when it is rotates, it will collect the current from the commutator, and these braces will give the collected current to the load system. And these are the references we are taken from the Google networks, okay. Thank you.